Okay, in this video we're going to talk about how to rationalize the denominator. So what the idea is, we're going to try and make the denominator less complicated. We're going to make the denominator no longer have radicals. We're going to make it rational, or just simple fractions. So that's what the name means, rationalize the denominator. Denominator meaning bottom, rationalize meaning make it simpler, make it just a fraction. Okay? The way we're going to do this is, just like with fractions, we are allowed to multiply the top and bottom of a fraction by a number, as long as we multiply by the same number. So for instance, 2/3, if we multiply top and bottom by 2, we would get 4/6, which is the same as the original number. As long as I multiply the top and the bottom by the same thing, I get something that's equivalent to the original. Okay, let's try that for this expression. 2 divided by the square root of 5. I want to multiply by something so that hopefully my answer is simpler in the sense that it doesn't have any radicals in the denominator. So we want to multiply the denominator by something so that it no longer has any radicals. And if you think back to the previous video, we said a square root of a square doesn't have a radical anymore. They cancel each other out. So why don't I make the denominator into a square? So square root of 5, I want this to be the square root of 5 squared after multiplying by some unknown mystery number, because then the square root of 5 squared is just going to be a 5. And so if we're able to figure out a way to do this, we will have rationalized, we will have made the denominator simple. And the way to do this, the way to turn 1 square root of 5 into a square root of 5 squared, is to multiply by another square root of 5. So that's what I need to multiply by. But just like with my 2/3 example that was on the board, I can only multiply a fraction by a number if I do the same thing to the numerator and the denominator. Otherwise, I've changed the meaning of the fraction. So I need to do the same thing in the numerator as well. Okay, and now let's calculate. So I had to do some thought process to figure out, okay, what am I supposed to multiply by? Apparently it's the same radical you see in the denominator. And then do the same thing numerator and denominator, and now let's work out the top. 2 times square root of 5 would be 2 square root of 5. And I'm just going to leave it like that. I don't have to simplify that. I will leave it that way. So one byproduct of rationalizing the denominator is that typically your numerators get more complicated. We're multiplying by a radical that hopefully makes the denominator not have radicals anymore. The numerator will get more complicated instead. Okay, I'm going to erase this problem, and we're going to instead look at this one. I may regret this decision, but this is what happens when you make up random numbers. Okay, so let's try that example. So I have a radical in the denominator. I would like to rationalize it. And again, just think about, what do we want to have happen? At the end of the day, I want to have a cube root of 7 cubed, so that the cubes and the cube roots will cancel. And so how do I turn a cube root of 7 into a cube root of 7 cubed? Well, I can't just multiply by a cube root of 7. I'm going to have to multiply by cube root of 7 twice, or cube root of 7 squared. So this is an expression I picked because I want to make sure that it works out to nice and simple rational numbers. Cube root of 7 cubed spits out just 7. And then what do I need to multiply a 7 by to get 7 cubed? Well, I need to multiply 3 7s together. We only have 1, we need to multiply by 2 more. Okay, so multiplying the denominator by that, I have to do the same thing, numerator and denominator. And so then the numerator would be 3 times the cube root of 7 squared. And then the only thing I can do that could simplify that, 7 squared, I'm just going to write as 49. So again, we've rationalized the denominator got simpler, the numerator got much more complicated as a byproduct. That's okay, our goal was only to make the denominator simple. I should probably take a second here to explain why we do this. If you look back at the two expressions that we are now saying are equal, if you're working on a problem with your partner and your partner gets this answer and you got this answer, it looks like, man, we must have done something wrong. We got terribly different answers. Not necessarily. Those are actually the same thing. So there's two ways to work around this. One is to type everything into a calculator and make sure they're the same decimal. The other way is to write them in a standardized way. And it turns out the standardized way that we've picked is to make the denominators as simple as possible. Okay, another reason that we do this, that we're bothering to teach you this technique of rationalizing the denominator, is that sometimes this method is going to be useful in making other complicated problems simpler. You're going to use the same steps. Okay, anyway, I think I'm going to erase and try one more example of rationalizing the denominator. Okay, let's try this out. So I see a square root of 3, and intuitive first thought would be, well, hey, multiply it by square root of 3. It turns out that's not what we want to do, but let's talk about why. If we multiply it by square root of 3, we have to do the same thing on the top and the bottom. And then the bottom is actually more complicated than it at first appears, because we've talked about already, there's implied parentheses around the denominator and numerator of a fraction. So the denominator is actually parentheses 2 plus square root of 3 times square root of 3. And so I'm actually going to have to distribute. We have a number times a sum. We have square root of 3 times 2. And we have square root of 3 times square root of 3. Square root of 3 times square root of 3 would actually be 3. And so compare this to the original thing we had in the far left. The denominator does not look any less complicated. It's still got a radical in it. So we've been unsuccessful in getting rid of the radical. Along the way, though, we have made our numerator more complicated. Yay! So we need to try something else. This is not the right thing to multiply by because of this implied parentheses and the fact that we have to distribute. So just be really careful that we do have to multiply the entire numerator and the entire denominator by this number that we're choosing to multiply by. Okay, so let's erase and see what should we pick to multiply by instead. And this is not something that you would probably guess. What we're going to have to multiply by is the same expression we see in the denominator, but with the opposite sign. So flip pluses to minuses, flip minuses to pluses. Take my word for it for just a second. Let's see what happens. So implied parentheses in numerator and denominator would give me 5 times parentheses 2 minus root 3. And in the denominator, 2 plus root 3, 2 minus root 3. Okay, on the top, we're going to have to distribute a 5. So 5 times 2. And 5 times square root of 3. On the bottom, we actually see parentheses times parentheses. So we're going to have to distribute, or we're going to have to FOIL. So hopefully you remember FOIL. If you have 2 terms multiplied by 2 terms, the rule FOIL says you multiply the first in each pair of parentheses, the outside in each pair, the inside in each pair, and the last in each pair, which is basically just a cheap way of remembering every term from the first parentheses has to get multiplied by every term in the right parentheses. It's basically just the souped up version of the distributive property. So we're going to have 2 times 2 as our first term. Let's see, outside would be 2 times negative square root of 3. Inside would be square root of 3 times 2. And our last would be square root of 3 times negative square root of 3. So this is our FOIL rule for distributing 2 terms times 2 terms, FOIL, meaning first, outside, inside, last 2. Neat thing that's going to happen though is notice our outside and our inside. The reason we picked the same thing with the opposite sign is when we actually find our outside and our inside, this is 2 times the square root of 3, this is negative 2 times the square root of 3. Those two are negatives of each other, they should add up to 0. So they're going to disappear. This one, square root of 3 times square root of 3 is just going to be a 3. Running low on room on my board, but we end up with 10 minus 5 square root of 3. And let's see, 2 times 2 would be a 4 minus 3. I'm going to stop there, but hopefully we see how we would simplify it. 4 minus 3 is 1, and then anything divided by 1 is itself. So it should just end up being equal to the numerator.